Oh, sorry. Caught me napping there for a minute. You know, it was a tough spring break. I had to go to the kitchen occasionally, go in the back room, watch some TV, play some video games, do some work. You know, it's a tough week. I'm relaxed now and I'm better. I'll be moving on. I need a little music or something to get me going. Let me see something here.
You
Gotta
keep
keep
'em
them separated. Well, that's a song that'll pump you up a little bit, although not really. It's a song from my youth. I don't know if you know it, but the song is called Come Out and Play. And you heard those lyrics, keep them separated. That's what we're doing, people. We are separating differential equations to solve them. How'd you like that little segue? If not, sorry. But there we doing, people. We are doing separable differential equations. What does that mean? Well, we did a little bit of differential equations before. We verified that they were true or not true. And a differential equation is simply a function where a derivative is a part of the function. And it is possible to solve them. So I'm going to show you a different way, not a different way, but a further way of solving differential equations. We did them a little bit. I'll show you again. All right, what is a separable differential equation? Well, first of all, you know what a differential equation is. A differential equation is an equation where it has a derivative in it. There, that's a differential equation. We can solve it. We can solve it by realizing that y prime is simply dy dx, and write this properly. If I multiply both sides by dx, I get this. That's now separated, which means all the y's are on one side, all the x's are on the other side. So a separable differential equation is simply a derivative in terms of both a function of x and a function of y. That's all that it is. Here's a differential equation. There's a function of x multiplied by a function of y. That's a separable differential equation. Separable because we can separate them. We can put all the y's on one side and all the x's on the other side. That's all that it means. I mean, here's another separable differential equation. There. There's no x values, but the x value, would that be 1? The derivative is a function of a y value times an x value. And this is actually called a homogeneous differential equation, and we don't have to worry about that though. We are only going to be worried about separable differential equations. Now you might think, well, if we have these things like homogeneous differential equations, and we have something you haven't learned to call a logistics function, and these are all things that are a part of differential equations, but we don't learn them in this course. Does that mean they're not important? What I want you to realize is Calc AB covers 1.5 years of college calculus. We have already done all the Calc 1 stuff. So if you go to college right now and take a Calc 1 class, we've done it all. Calc 2, you will recognize a lot of Calc 2 in the very beginning of stuff we've already done, but they're going to take it and stretch it further and fill in the gaps and give you more details and teach you more things. But your Calc 1 and what we did in class, and you did before I got here, are all in Calc 1. And you know that stuff. That's why I wasn't pushing to get through things. I wanted to make sure you understood what we did together well. Now what we're doing now is something that you wouldn't get in a Calc 1 class, but it's part of this course. and it will be on the AP test. So that's why you're learning it. So don't worry about things like, oh, well, don't worry about this and we skip that. It's all because you're going to see it again. All right. Let's solve a separable differential equation. First of all, is it differential? Is it separable? Well, notice how we just have the x's over here. So I'm going to always, what I do is rewrite the y prime as dy over dx. Now, not quite separated yet, because I've got an x over here. I know it's a dx, which is a differential, and we need that. So I'm going to multiply both sides by dx. I'm not always going to show you this step. We're going to assume this in many cases from now on. So multiply both sides by dx. And now we have separated them. So every time we separate a differential equation, I always think of one thing. The song really is not about separating differential equations, you might have guessed. It's really about separating people, and it's really not a very nice song. But I always think of that. When I think about solving separable differential equations, I can't help myself. Ever since I first heard that song, my first thought was, oh, separable equations. Because you know math. Math is not a very nice thing. It's very discriminatory and segregated. Keep the y's on one side, keep the x's on the other, then we can integrate them. As long as we have these differentials, dy and dx. Now there's no function here. It's just dy. So we assume the function is 1. What would give us a derivative of dy? Well, the antiderivative of dy is y. Okay. The antiderivative of 6x squared plus 4x. It's been a while, so we'll recap. Remember, you raise the power by 1, and you divide by it. You raise the power by 1, and you divide by it. Plus some constant we don't know. Now you might be thinking, wait, I didn't put a plus c over here. Well, technically it's there, we just didn't deal with it. What I mean by that is, could I have put y plus some constant, we'll call it c sub 1? Yes, because if I take the derivative of this, I get 1, and the derivative of c, the derivative of constant is 0. So this would give me, this would be the derivative of this. So this would be another c value, because if I take the derivative of this, I end up with 6x squared plus 4x. Then the derivative of constant is 0. But we assume there's just one constant, because couldn't I subtract c1 from both sides of the equation? So technically, I only have one constant value. That's all that I need. So let's simplify this a little bit. 6 divided by 3 is 2. And we'll just say plus some constant value. This is our solution to our separable differential equation. So if I take the derivative of this, I should end up with that. Derivative of y is y prime. The derivative of 2x cubed is 6x squared. The derivative of 2x squared is 4x. The derivative of a constant value is 0. That is a solution to a differential equation, a separable differential equation. Now, let's put some meat on it. Let's figure some other things out that we haven't quite done yet. All right, first thing I'm going to do, rewrite that as dy dx. Multiply both sides by dx. You end up with this. All right, separated? Not yet, because we have a y here. We got to get it over here. So we'll divide both sides by y. All right. What do you think? Is it separated?
You gotta keep them separated.
It is. Okay, that's the last time I play that song. Sorry. All done. But check it out. Offspring. Come out and play. All right, it is separated. All the y's over here, all the x's over here. Now we will integrate them. Or we can integrate them because we have a y value and a dy, an x value and a dx. Remember, that's your integrating factor called a differential. It basically goes away. It becomes nothing, but we need it to say, hey, this is our integrating factor. Okay, what's the antiderivative of 1 over y? Well, here we go. Natural log, and we've got the y in absolute value because we need the y to be positive. The integral of x, 1/2 x squared, because we raise the power by 1 and divide by it, plus a constant. We need a constant. Okay? Now, if we can solve for y, we should. So how do we solve for y? What's the inverse of a natural log? Well, it's this. We take them both and make them powers of e. So e to the natural log of y is just y. Now be careful, this is being added together. So this is really e to the 1/2 x squared plus c. You might be thinking, oh, that's good, we're done. Technically, you are done. Okay. However, I want you to think of it this way. We're going to put a little c sub 1 here. Because if I can rewrite this, do you see why this is true? Do you see? If we take powers and we add exponents, it's the same as multiplying the bases. The same way this is true. What's x cubed times x to the 4th? Well, you know what's x to the 7th because you take 3 plus 4. Well, would it be possible, even though it's kind of weird, we never wrote it that way, could I write it as x to the 3 plus 4? Sure I could. Same way this. This was 1/2 x squared plus c. So the 1/2 x squared, well, that's going to all stay here with this one. And then the plus c sub 1, I mean that those exponents become the e raised to those powers. So our final answer, and this is just a very common thing we do, we take that e to the c sub 1 and just make it another constant, a giant c. And if you notice, this looks familiar to something you did last year, then you're going to see what our next section is all about. I don't know, I'm not going to give much anything away, but that might look familiar to a formula you used last year. Not the exact formula, but just its general form. Okay. But we'll let that go till the next lesson. All right, we'll do 2 more, then we'll end this video, and then I'll pick up another video doing the last 4. Oops, that's not right errantly. Alrighty, let's pick another color. I like this one. Okay. And there we go. Solve the differential equation. So what I'm going to do is I'm going to change this to dy dx. Alright, now I got to separate it. I usually separate this one first. That way I know where the x's and y's have to go. So that all the x's have to go over here. I'm going to multiply both sides by dx. We have now separated the differential equation. Once it's separated, we can integrate it. What's the antiderivative of y? Good. And the antiderivative of sine. Remember, the derivative of sine is cosine, so the antiderivative is negative cosine plus a constant. We'll just call it c sub 1. You're going to see why in a minute. Okay, so now solve for y. Multiply everything by 2. And then take the square root I'm just going to call that just some big constant c. I'm not worried about the 2c1 right now. However, we don't know if it's going to be positive or negative. It could be either. So we're going to keep both possibilities. And maybe thinking, wait, if I got a negative 2 cosine, I can't take the square root of a negative number. But you know, there's two things we don't know. What's that value of c? That value of c might make it positive all the time. Or sometimes the cosine itself can be negative. So multiplying by a negative will give you a positive. So this is the correct solution to that differential equation. We don't know if it's plus or minus, so we make sure we put them both because they're both possibilities. That's the general solution. What do you guys think so far? Good, bad? All right. Okay, last one for this video. Now that does not look very separable to me at all. How in the world are we going to take, well, first of all, we'll write this as dy dx. How can we possibly separate these? I can add the y over there, but remember, separable equations are supposed to be products of x and y. These are sums of x and y, and these are together. It's a mess. Well, here's a little trick. See if you recognize this way back from probably, I don't know if you did it last year in pre-calc at all very much, or algebra 2, factoring by grouping. Notice this group here. What do they have in common that I could factor out? They have an x. Then I look at this group. What do they have in common that I could factor out? Negative 2. Negative 6 divided by negative 2. And we'll put both of these have in common now. You guessed it. They both have a y plus 3 term in it. So if I take out the y plus 3, don't forget, if I take this out, they both have a y plus 3. That leaves me with x minus 2. All right, not separated yet, but we're working on it. We're almost there. I need to get this x is going to come over here. So I'm going to divide this y plus 3 to move it over here. Would you say separated? And hopefully yes, because they are. All right. So now we can integrate it. What's the antiderivative of 1 plus y over 3? Well, it's still this, so we're still okay. What's the antiderivative of x minus 2? Oops. It'll be x squared, but then we divide by it. So 1/2 x squared minus 2x plus some constant. Now notice I put c sub 1 again because the constant is going to go through some changes. Okay? All right. So inverse of the natural log is e, so we'll think of it this way. Get y plus 3 equals e to the 1/2 x squared minus 2x plus c sub 1. Now I'm not going to bother too much crazy simplification, but I do want to break up this constant. So wouldn't this be the same as e to the 1/2 x squared minus 2x times e to the c sub 1? Okay. Now, what that does is that will just give us, let's move it down a little teeny bit, y equals, this is going to become a big C, we'll put it out in front, e to the 1/2 x squared minus 2x minus 3. So this is the general solution to the differential equation. All right, a little bit more complicated that time. but the idea is always the same. Take your variables, separate them. Once they're separated, integrate them. Once you integrate them, solve for y. So hopefully that made some sense. There are many other videos you can check out online. Search for separable differential equations, and there are videos of other people. So if you want another perspective, go ahead and look for it. If not, hopefully you got this. We're going to do the next 4 in my next video. So I will see you soon.